Hi boys and girls, welcome to 4th grade Eureka Math Module 5 Fractions. Today you'll be learning lesson 13. In this lesson you'll be able to use benchmarks to compare two fractions on a number line. You will need the following materials for today's video lesson: your dry erase sleeve, dry erase marker, and eraser. You're also welcome to use your math notebook if you prefer. As I work out problems in this video, you are expected to do them too on your dry erase sleeve. You may pause the video if I'm going too fast or if you need to rewatch something. Let's get started with our application problem. Mr. and Mrs. Chrystall went for a run. Mrs. Chrystall ran for 6/10 of a mile. Mr. Chrystall ran 2/5 of a mile. Who ran farther? Explain how you know. Use the number line and benchmarks 0, 1/2, and 1 to explain your answer. So pause the video while you work this one out. Press play when you're ready to check your work. Okay, I'm going to use my fraction benchmarks to help me figure out this problem. So let me label 1/2 on here. So Mrs. Chrystall ran 6/10 of a mile. So I want to figure out an equivalent fraction to 1/2 using tenths as my unit. So I know that 5/10 is equivalent to 1/2. 5 is half of 10. I can also add that 1 whole is the same as 10 tenths. Now, when I'm trying to plot that on my number line, I have 5/10 and 10/10. I know that 6/10 is going to be just 1/10 bigger than 5/10. So I can put 6/10 on my number line. I also know that 2/5 is less than 1/2. We talked about this in lesson 12 for a while, but 2/5 is less than 1/2, while 3/5 is more than 1/2. So I can put 2/5 on my number line, maybe right about here. So I can plot them on my number line without measuring the exact distance and doing every single hash mark on there. And I used my benchmark fractions to help me figure out where to plot them. So I can see that 2/5 of a mile is less than 1/2, while 6/10 of a mile is more than 1/2. So the question is, who ran further? 6/10 of a mile is a farther distance than 2/5, so Mrs. Chrystall ran farther than Mr. Chrystall. All right, let's look at the fraction 6/4. My first question for you is 6/4 bigger than or less than 1? So think about the fraction 6/4. Is it bigger than or less than 1? Okay, hopefully you said that 6/4 is bigger than 1 whole. We know that 4/4 is 1 whole. So if we have more than 4/4, like say 6/4, that means it must be larger than 1 whole. So I want to draw this as a number bond. So I'm going to put 6/4 in a circle, and I'm going to think about how it makes sense to break it up. I could break it up into 6 circles, with each circle having 1/4 in it, but I think I'm going to break it up into 4/4, or we can call that 1 whole. And if I use 4/4, I have 2/4 left. So basically that means 4/4 plus 2/4 equals 6/4. So if I wanted to write that as a mixed number, I can say 4/4 is 1 whole, and I have 2/4 remaining. So when we get fractions written as 6/4 that are bigger than 1, it can be helpful to make a number bond and figure out what the answer is as a mixed number. So when we're plotting on a number line, we know how much past 1 whole to go. So let's compare fractions using benchmarks 1 and 2 now. This question asks us to compare 7/8 and 6/4 using benchmarks. In the last problem, we just figured out that 6/4 is greater than 1 whole. So you'll notice our number line looks a little bit different. We have 0, 1, and 2 on our number line. So we're going to use a lot of our same reasoning from yesterday's lesson to add these numbers to our number line. So let's go ahead and we'll start with 7/8. Well, if I think about 7/8, I know that 1 whole is the same as 8/8. So 7/8 is going to be 1/8 less. So 7/8 can land right there on my number line. Now, when I start thinking about 6/4, I know that it's greater than 1 whole, and I have to figure out how much greater. Well, in the previous problem, I found out that 6/4 was the same as 1 and 2/4. So I know it's definitely going to be past 1. It's going to be somewhere along this line between 1 and 2. So I have to think of where would I put 2/4 on a number line. Well, I actually know 2/4 is equivalent to 1/2. So to label 6/4 on my number line, I would put it right here. 1 and 2/4, or 1.5. Now I'm able to compare these. I can say that 7/8 is less than 6/4. So we're applying our benchmark knowledge from yesterday to today's lesson, and we're adding more benchmarks on, larger than 1 whole. Right. I would like you to try this one on your own. Compare 5/3 and 9/5. On your dry erase sleeve, I'd like you to draw number bonds for each of those numbers, and then locate 5/3 and 9/5 on the number line to compare. When you think you are done, press play on the video and check your work. All right, I started by drawing my number bonds for 5/3 and 9/5. This helps me to see 1 whole and the fraction, 1 whole 5/5, and the fraction that's left over. So when I start to plot, I know both of my fractions are going to be greater than 1 whole, but they're going to be less than 2 whole. So both of my fractions are going to fit in here. All right, so 5/3, which is the same as 1 and 2/3. So I need to start at 1 whole, and I need to move over 2/3. So I could do my dashes and break the whole thing up into thirds, but I don't have to. I can just plan to make sure that I have a distance that's about 1/3 away, because 2/3 is 1/3 away from the next hole. So this mark right here represents 5/3, or 1 and 2/3. Okay, now for my next one, 9/5, I know that it's 5/5, so that's at 1 hole already, and then I need to go 4/5 past 1 hole. Instead of dividing my whole number line up, I'm really going to think of this 2 hole, this second hole being another 5/5. So my 4/5 is really just 1/5 behind the 2 hole. Because if I had one more 5th size piece, I would be at the next whole number. So I need to go back 1/5. Now my question is it going to land on this side of 5/3? Or is it going to land on this side of the 5/3? So I have to use some number sense about my fractions. When I think about my fractions, I'm going to draw 2 sample number lines down here. And I'm going to break 1 into thirds and 1 into 5ths. Label my whole. Okay, so now this one has 3rd size pieces. And let's make this one have 5th size pieces. So we can count. We have 1, 2, 3 pieces, and 1, 2, 3, 4, 5 pieces. So which pieces are bigger, my 1/3 pieces or my 1/5 size pieces? So if I look at this, my 5th size is quite a bit smaller than 1/3 size, because in this model, my 1 whole is being broken up into 5 pieces, while up here it's only being broken up into 3 equal pieces. So the fraction that's broke up into fifths is going to be a lot smaller. So with that reasoning, I can take my 1 4/5, or 9/5, and I am going to move it so it is just about 1/5 away from 2 whole. So if we think about these, we have this one, 5/3, which is 1 2/3. So we need it to be 1/3 away from the next whole number. Because if I added another third to this, we would have 3/3 and it would be equal to 2 whole. So it's just 1 short of being 2 whole. Up here, this one is 1 4/5. If I added another fifth here, we would have 5/5 and 5/5, which would be 2 whole. So again, we're just short 1/5. So on my number line, I should just be 1/5 away from 2 whole. A 1/5 piece is smaller than a 1/3 piece, and we could see that down here. Thirds are bigger, fifths are smaller. Okay, we're going to compare fractions using the benchmark 1 1/2 this time. So let's start by adding 1 1/2 to our number line. So we have that on there. So we're being asked to compare 11/8 and 5/4 this time. I would like you to draw number bonds and then without measuring, plot the fractions on your number line. Press pause now. Okay, while the video was paused, I went ahead and drew my number bonds. So 11/8 is the same as 8/8 and 3/8. 8/8 is 1 whole, so it's 1 3/8. For 5/4, I broke it up into 4/4 and 1/4. 4/4 we know is 1 whole, so 5/4 is the same as 1 1/4. I also took the opportunity to add my benchmark fractions in the units I'm using above. So I'm using eighths in blue, and I'm using fourths in red. So I know that 1 whole is the same as 8/8, and 1 whole is also the same as 4/4. I went ahead and I added it for my benchmark fraction of 1 1/2. So 1 1/2 I know is the same as 1 4/8. 1 1/2 is also the same as 1 2/4. So now I have common units that's going to help me to put these on my number line. So let's start with my first one. So I have 1 3/8. So I have to start at 1 whole and I have to go 3/8 over. So when I take a look at my 1 1/2, I see that 3/8 is just 1/8 less than 1 1/2. So I can put my line right here, and I can label this as 11/8. So again, 11/8 is the same as 1 3/8. So 1 3/8 is 1/8 less than 1 4/8. So that's how I knew to put it right here. Now I have 1 1/4. So this is going to be past 1 whole. I have to figure out how far is it going to go over. Well, I know that 1 1/2 is the same as 1 2/4. I have 1 1/4. It is 1/4 smaller than 1 1/2 or 1 2/4. So I'm going to put that right here, and I'm going to label this as 5/4. So both of my fractions, this one being 1 3/8, was 1/8 smaller than this mid 1 1/2 right here. So I had to go back 1/8. My second fraction, 1 1/4, is 1 smaller than 1 2/4. So it's 1/4 smaller than that. So I had to go back 1/4. 1/8 is smaller than 1/4. So that's why my 1/8 piece is closer to 1 1/2 than my 1/4 piece. Now that I have them labeled on there, I can compare my fractions like I was asked to do. And I can say that 11/8 is greater than 5/4. So I use what I knew about my benchmarks. I used my 1 1/2 benchmark right here. Did some conversions to eighths and fourths, so it's easy to figure out where my fractions fell on the number line. And then I could easily see how they compare. This next problem is really similar, it just has different fractions. Compare fractions using the benchmark 1 1/2. Compare 11/8 and 10/6. Draw number bonds, plot the fractions on the number line, and compare. So I'd like you to work on this. Pause the video and press play when you're ready to check your work. Okay, go ahead and check your work compared to mine. I started by making number bonds for 11/8, just like the previous problem. 11/8 is the same as 1 3/8. And then I did a number bond for 10/6. I broke that into 6/6 and 4/6, so it's equivalent to 1 4/6. The next thing I did was add 1 1/2 benchmark to my number line. So I wrote it as 1 1/2 as my benchmark, and then I wrote it as an equivalent fraction as 1 4/8, because 1 1/2 is the same as 1 4/8, and then I wrote it as 1 3/6. So I have all of my benchmarks on there. Now for plotting. For this one, 1 4/6, I looked at my 1 1/2 benchmark, which is 1 3/6. So I know that my fraction should be 1/6 larger. So 10/6 would land right here. For my purple fraction, 11/8, I knew that 11/8 was the same as 1 3/8. So when I look at my benchmark fraction, 1 1/2 in eighths units, I have 1 4/8. 1 4/8 is just one bigger than 1 3/8. So I know that I need to be just 1/8 behind 1 1/2. So I'm able to see that 10/6 is a little bit bigger than 1 1/2, while 11/8 is a little bit smaller than 1 1/2. With that, I'm able to compare them here. 11/8 is less than 10/6. So now we're going to use benchmarks to compare two fractions. You'll notice this slide does not have a number line on it. You are more than welcome to use a number line to help you solve these problems, but we're going to try to just reason through these using our benchmarks. So when I look at 14/10, I automatically know that that fraction is going to be larger than 1. So it's going to be somewhere between 1 and 2. And when I look at 7/5, I see that same thing. So a benchmark that might be helpful to me is that 1 1/2 benchmark. Again, I want to think of that as tenths and as fifths. Okay, so I'm going to think of it as tenths and as fifths. So I know that 1 1/2 written as tenths would be 1 5/10. 5 is half of 10. So if I had 10 pieces of something and I wanted half of them, I would take 5 of those pieces. 1 1/2 is the same or equivalent to 1 5/10. I can then take 7/5 and try to think of that in halves. Now if I had 5 pieces of something, how much would half of 5 be? Remember, this is something we talked about yesterday. When we have odd units or odd denominators, it's really tough to make halves because an odd number can't be cut into half evenly. So one thing that we talked about yesterday, even though it's not properly written, it would be like 1 and 2.5 fifths. Basically, what I like to think about for this one is that, let's see how we can write this. 1.5 is less than 1 and 3 fifths, and 1.5 is greater than 1 and 2 fifths, because that 1.5 is right in between 2 fifths and 3 fifths. So you can kind of think about it a little bit like that. So now it might be helpful to start thinking about my 14 tenths as a mixed number. Well, if I had 10 tenths, that would be 1 whole. And if I took 10 tenths away from 14 tenths, I would have 4 tenths remaining. So 10 tenths and 4 tenths equals 14 tenths. Instead of writing it as 10 tenths, I'm writing it as 1 whole plus 4 tenths equals 14 tenths. All right, let's do the same thing for my 7 fifths. If I took 5 fifths, I could write it as 1 whole. If I took 5 fifths, I would have 2 fifths remaining. So now that I have them both as mixed numbers, I can take a look over here and see that 1 and 5 tenths is 1/2. So 1 and 4 tenths is just a little bit less than that. And then I can also see that 1.5 is also 1 and 2.5 over 5. Or we know that it's going to be, this is going to be just a little bit less than 1 and 1/2. So both of these fractions are actually pretty close together, it seems like. They're both just a little bit smaller than 1.5, because we have all of our equivalent fractions to 1.5 right here. This 4 tenths and 2 fifths seem like they're both just a little bit smaller than 1.5. If I can't reason through it with benchmarks, I might have to draw some sort of model to be able to prove this. Let me start by drawing 2 fifths. 1, 2 fifths. Now, I see that I can decompose my fifths into tenths. I can divide that there. So, what I just realized is that 2 fifths I started with, when I decompose it, I now have 1, 2, 3, 4 tenth size pieces. Oh, so that's why they're so close. 4 tenths and 2 fifths are equivalent fractions. So 1 and 4 tenths and 1 and 2 fifths are equal. So let's review that. As I was starting to compare these fractions, I realized that they were both really close to 1 and 1/2. They were both just a little bit smaller than 1 and 1/2, even without my number line. So I had to dig a little bit further, and that's when I was able to realize that 2 fifths is the same as 1, 2, 3, 4 tenths. So I was able to determine that they're equal. Okay, 6 fourths compared to 11 tenths. I'd like you to use benchmark fractions to compare these two fractions. When you're done, press play on the video. Okay, I'm going to start by writing 6 fourths and 11 tenths as mixed numbers. So if I have 6 fourths, 4 fourths of those are 1 whole, and then I have 2 fourths remaining. And then if I have 11 tenths, I know that 10 tenths would make 1 whole, and I have just 1 left over. So I have 1 and 2 fourths, and 1 and 1 tenth. So they're both greater than 1 whole, but we have to see by how much. So I can think about my benchmark fractions. Let's say, let's go with 1.5 again because these are both over 1 whole. So I can write 1.5 as 1 2/4, or I can write 1/2, 1 1/2, as 1 5/10. So these are all equivalent fractions. Now I can see that 1 2/4 is equivalent to 1/2, 1 1/2, and 6/4 is equivalent to 1 2/4. So that means that this one is 1 1/2. Okay, now I have 1 1/10. 1 1/10 is less than 1 1/2 because 1 1/2 is equivalent to 1 5/10. So this is less than 1 1/2. This is equal to 1 1/2. So that tells me that this one has to be smaller. This is 1 1/10, so it's only 1/10 bigger than 1 whole. Well, this one is 1 1/2. So we can add our symbols in like that. All right, boys and girls, thank you so much for watching this video and working really hard to understand these concepts as we went through these problems together. Right now, I'd like you to grab your problem set book and work on the lesson 13 pages. Rewatch this video or parts of it if you need help. Remember to work hard, ask your peers questions if you have them, but make sure any conversations you have are about math and math only. If you have questions from this video or from this lesson, please write them down and ask me later. Thank you.